I'll say again, good morning class and welcome to algebra. Again, slope-intercept form. We all know that slope means the direction that the line is going. This particular slope is positive or negative? Everybody, what do you think? Negative. And the intercept, where it crosses the y-axis, this one happens to be positive. If I move it down there, it is negative. And if I move it there, it is 0, just like that direct variation. So let's get to it. We're going to write these down in slope-intercept form. If the slope is 2/3 and the y-intercept is -9, this was on our last test. We had to have the ability. We had to have the ability to write this in slope-intercept form. So we would say the slope, the m part is the slope, and the b is the intercept. So let's write in there 2/3. It's that easy. I'm going to put in 2/3. Remember, up 2/3. And of course, if I say that the b is -9, I could say plus a -9, but that's silly, isn't it? Because I could just say -9. So with a y-intercept of -9 and a slope of 2/3, y equals 2/3 x minus 9. If I have a slope of 3/4, 3/4 as we like to say, I'm simply going to write 3/4. Plus a -6, I'm just going to say -6. Easy squeezy. Now I can visualize both of these lines. If I were to sketch the axis, no, wrong one. Hang on, let me grab this tool here. I guess I don't have it. Oh, there we go. If I had an axis there, in both of these cases, I've got a positive slope and I've got a negative intercept. So if I were just sketching this, I know that it would look kind of like that. Because I have a negative intercept. I've got a negative intercept and I've got a positive slope. So just sketching, I think, would look something like that. Both of those. Now let's see what's wrong with this equation. Let's correctly identify this one. If we have a slope of -1. Now a slope of -1, remember what slope means. Slope equals rise over run. Now, if I have a slope of -1, that's an odd-looking fraction. I could think of that as -1 over 1 or down 1 over 1. As a coefficient, that's the same as the number -1. On all of these, let's start here. This has a slope of 2. That's not it. Ooh. This one also has a slope of 2. Let's look at the choices A and C. How many x's do you see there, everybody? Do you see an x there? I do. How many? There's 1. This one has a slope of 1. That would be a positive 1. When I write this equation in A, this has a slope of -1. How many x's do I see? I see the opposite of x. The opposite of x is the same as -1 times x. I mean, I could take this equation And I could represent this as negative 1 times x. If I wrote it that way, I could see that the slope is negative 1. Negative 1 times x is just plain negative x. This is your equation. Now that did come up last week when some of you were trying to graph it when it just said when the slope is just plain x or negative x. So again, this is the same as that. So your choice is A. Let's follow along. Easy squeezy Monday. So I want you to be able to use the slope, whether you're using the equation for slope, which we'll use in subsequent problems, or we can just intuitively look at the rise over run. I'm going up 4 and I'm going over 6. I've got these points right here. I can read them. Plus I just gave it to you, right, Paul? I go up 4 over 6. I'm going from negative 8 up to 4. That's an increase of 4. That is my rise. So if I say rise over run, I'm going up 6. And when I say over, I'm always talking about over to the right. And I'm saying, oh, I'm sorry, up 4 over 6. My bad. Over 6. I can read that. The change in the y's, the vertical is 4. The horizontal is 6. But I can simplify that. 4 over 6 dividing by 2 is, of course, 2 over 3. That's my slope. Up 2 over 3. My intercept, where does it cross the y-axis? It's right there. Remember, the y-intercept is also the value when x is 0, y is negative 8. I can just read that directly from here. So I'm going to write negative 8. Plus a negative 8 or minus 8. So all of these, or these three, you're given this little graphic here, down and over. Let's look at this one, the slope. The slope is down 1 over 1. So what's negative 1 divided by 1 is, of course, negative 1. And what's negative 1 times x? It's just plain minus x. This one has a slope of negative 1. What's up, Dom? You got a question about this? Hurry back.
Yes.
I don't want you to miss anything. Down 1 over 1. That's got a slope of negative 1. And of course, we're going to find the intercept. The intercept simply means where it crosses the y-axis. Now, some students, believe it or not, some students in my geometry class are getting confused. They're looking at this. This is an intercept. Right, Gideon? This is an intercept, but that's the x-intercept, where it crosses the x-axis. See, that's negative 3, 0. That's the x-intercept. This is the y-intercept. You want the one where it crosses the vertical axis. So when x is 0, y is negative 3. Or where it crosses the axis is just plain minus 3. So when I read the slope-intercept form the line right there. Y equals mx plus b. The m is -1. The b is -3. Y equals the opposite of x, -3. Oh, I can see where this is going. All right, so that was some. Oh, and there's one more in this series, I think. Yeah. Let's use that same tactic where since we have the slope illustrated like this, down 2 over 1. We know the rise, that is a negative rise. A rise of -2 over 1. I can simplify that to be the integer value, -2. Right, Gideon? I'm up here. So I'm going to replace the m. I'm going to replace the slope with -2. That stands for down 2 over 1. And then again, I need to see where it crosses the y-axis, the vertical axis. And it crosses the y-axis, everybody at -2. So when x is 0, y is -2. The y part is the b. That's the -2. -2x, the slope of -2, crossing the y-axis at -2. Down 2 over 1. Down 2 over 1, crossing the y-axis, or a y-intercept of -2. Hey, that's kind of fun. Whew. Yeah, these Mondays are always a fast and furious assignment. But this is just a little follow along today. I'll let you have a little more, you'll have a little more autonomy in the next few days. Except for, well, Thursday you'll have a lot of autonomy. You won't be here. Lucky you. All right. What's wrong with this equation? What is wrong with this equation? It's got a slope of 2 and a y-intercept of 7. Is that what that says? Messed up. What's wrong? Can anybody see it? What's up, Dane? What do you think?
The slope and the y-intercept are like
Yeah, they switched them, so it should be 2x plus 7. Somebody took them and they switched the slope with the y-intercept, so that was a mistake. You know, the author of this textbook writes these things called error analysis. They take common mistakes that we'll see. So perhaps you can say, oh yeah, I've done that before. Okay, this one's a pretty obvious mistake. The next one happens actually quite a bit. In my experience, I've seen it a lot on your papers. Well, not you collectively, but your contemporaries. Let's check this one out. There's something wrong with this. Zero minus 4 over 0 minus 5. Now, we do remember that we take a point and we're going to call it an x1, y1. We're just going to say x1. This is how when we use the slope formula, we say x1, y1. And then we take the other point and we call it x2, y2. Well, which one is which? And it really doesn't matter. I'll make a copy of that, and I'm going to call it x2, y2. Well, personally, I always take the one on the right to be the x2, y2, and this one the x1, y1, if we're going to use the formula. Because we're going to use the formula for slope in a little bit. Can you see what somebody did here? They took 0 minus 4 over 0, wait a minute, over 0 minus 5, ruh-roh. Well, they got part of it right. The difference of the y's typically would be the y2 minus y1 would be the 0 minus 4, but it'd be over 5 minus 0. And that's where the mistake was in this. A more common mistake I've actually seen is when people get the x's and y's mixed up. They put the difference of the x's on top. And look at the effect of this. All it does is toggle the sign. So now the equation, but it makes sense because when I look at the corrected equation, it has a negative slope. Just look at this. This equation, as I read it from left to right, has a negative or decreasing slope. Yes, our first week on standard time. Okay, let's practice using this equation. Now, I know we could look at the graph. I know you can look at that and just go rise over run. I know you can just say down, you're looking at that, you could say down 4 over 3. You could read the chart, but let's see if we can practice doing this. So go ahead and we'll make the first point. Think of the first point as x1, y1. And the second point as x2, y2. Now you can do it any way you want, but I usually pick the one on the left to be x1, y1. The one farther to the right, x2, y2. That's going to give me a positive denominator. And let's do the substitution. No, we're not going to do that. We'll verify it this way. So again, this is my x1, y1. This is my x2, y2. And the equation says y2, which is 0, minus 4 over 0 minus negative 3. It's good to explore our integer arithmetic. 0 minus 4 is negative 4. Well, 0 minus negative 3 becomes 3. So look what happens. I've got negative 4 over positive 3. A negative divided by a positive is a negative, so that means the entire slope is negative. It's negative 4/3. We can verify. We look at this line. And as we look at it from left to right, it's going down. We know it's negative. So that's our check. We checked our arithmetic. And it checked out okay. Now, it also goes through 0, 0. So I could just write the equation just like that. And some of you are probably thinking, we had an entire section on something called direct variation. That's where the y-intercept was 0. So y equals negative 4/3 x. I like that one. And again, that is an example of direct variation. Now I know you can verify it by using this. You can visualize down 4 over 3. And there's your slope of negative 4/3. But there's merit in being able to do it this way too, because what if these numbers, what if you weren't able to graph them? What if they were big, ugly numbers? We'd want to be able to work the equations as well. All right, so we'll do another example. And I'm going to pick this point, 0, negative 4, as x1, y1, and I'm going to pick 4, 0 as x2, y2. Those are both the intercepts. That they both happen to be the x and y intercept. So I'm going to take y2, 0, minus negative 4, y1, over positive 4, x2, minus 0, x1. 0 minus negative 4 is, of course, 4. 4 minus 4 is 0. And 4 over 4 is 1. And I can see that because I can go from here, up 1 over 1, up 1 over 1, up to here, up 1 over 1 to here. It looks good. It's got a slope of 1. And we pass through the y-axis at negative 4. So my slope is 1, and my y-intercept is negative 4. If I substitute into this equation, I got that. But of course, we're just going to write it a little cleaner, and we will write it as 1x. We're just going to write how many x's? I see 1. Plus a negative 4 is the same as minus 4. That is x minus 4. So you're writing that equation. Look at that. Y equals x minus 4. You know, going back to our substitution, I could put a value in there. Let's suppose I put in the number 3. 3 minus 4 is negative 1. So when x is 3, y is negative 1. Look at that. Checks out okay. Okay, one more graph, and then we're going to do it without a graph. Now, I like these 2 points. They were chosen to be a little so we can work with our integer arithmetic. We're going to take this one as x1, y1. And we're going to take this one as x2, y2. So get some practice using this slope form. Even though you could just look at this and say, yeah, I could see I'm going up 4 over 2. Just practice doing this. Let's do the substitution. Yeah, we don't need that. I'm going to substitute this way. y2 is 2 minus y1, negative 2, over x2 is 2 minus x1 is 0. I've got 2 minus negative 2 over 2 minus 0. Oops. And that's going to simplify to the whole number 2. Up 2 over 1, up 2 over 1. That's the slope. And we cross through the y-axis at negative 2. When I substitute into the form y equals mx plus b, I've got 2x plus a negative 2. So I'm just going to write that as 2x minus 2. All right, just 3 more. Dylan, you can do it. Hang tight. Here we go. No graph anymore. Let's just do it without the graph. I'm going to give you 2 points. I'm just going to call this one x1, y1. Call this one x2, y2. Doesn't matter, you could do them in either order. Again, I know that this one is farther to the right if I graphed it because the value of x is bigger. 0 is bigger than -3. But again, you could do this either way. Let's do our substitution. y2, -8, minus 1 over 0 minus a -3. Look at this, no picture, no graph necessary. And maybe we need to switch it around just to show. When I simplify this, I've got -8 minus 1. I've got 9 over 0 minus -3 over 3. Negative divided by a positive is a negative. I've got -3. Then, very conveniently, where all of these, one of the 2 points happens to be the y-intercept. When x equals 0, y equals -8. That is the definition of the y-intercept. Therefore, I know when all I've got to do for the b, y equals mx plus b, the b is -8. And of course, we're going to write it like that. Now, hang on. Let's just, in case there's any doubting Thomases, I want to take this. I want to take these. I want to switch them around. I want to switch this way. Let's just see how it comes out. So when I did my substitution, originally it looked like this, but now it's going to be, I'm going to mix it up. I'm going to say it's 1 minus -8 over -3 minus 0. Now, 1 minus -8 is 1 plus 8, which is +9. But -3 minus 0 is, of course, -3. And in the end, I still have a positive divided by a negative. I still have -3. So you see, I got the same slope. I got the same slope regardless of the order in which I selected the 2 points to be x1, y1 or x2, y2. So you decide how you want to do it. Or you just pick them at random. It'll always come out the same. All right, just a little bit more, and we're almost done. We're doing a whole sheet together today. Isn't that exciting? Yay. Oh, so again, see, I think I'm going to pick them this way. x1, y1, x2, y2. -4 minus 4. Ruh-roh. This is going to be funny. I know that -4 minus 4, any number minus itself, is of course 0. Now, it goes through 0, -4. If I were to put this in slope-intercept form, I've got y equals 0x plus a -4. And the -4 comes from this point right here. That's where it crosses the y-axis. So I know I know that 0 times x is 0. I can simplify this equation as y equals -4. So when I see this equation, y equals -4, yeah, that's in slope-intercept form. Slope is 0. If I wanted to sketch that, and let's suppose I did, let's pull up these, let me sketch these axes here. If you wanted to know what that looked like, y equals -4 would be a horizontal line like that. Now you don't have to sketch it, but you can if it helps you understand it. The slope is 0 is a horizontal line. And finally, x1, y1, x2, y2. So we're going to substitute, and this time we got ourselves a decimal. So let's substitute 1 minus 5 over 1.5 minus 0. One minus 5 is -4. -4 over 1.5. Now, I'm going to multiply the numerator and denominator both by 2 to get a similar fraction. -4 times 2 is -8. 1.5 times 2 is 3. So I can turn it into this more useful version of a slope, -8 over +3, or -8/3. Down 8 over 3. Down 8 over 3. And passes through the y-axis. Where does it pass through the y-axis? Everybody at what point? 5. Correct. 0, 5. So it crosses. So that means that B is 5. M is -8/3. So the entire fraction becomes -8/3. And the intercept is 5. And we'll call that, and I say we'll call that a day. You've got a few minutes. Finish it up, and on your way out, you can hand it in. And thank you for watching Nani Knows. Everybody who missed the class, we look forward to you coming back.